Hello, in this video we're going to take a look at some rational equations that become linear. Our first example, we have the fraction 3 over x minus 2 equals negative 3 over x plus 5 plus 15 over x minus 2 times x plus 5. All right, anytime we have fractions inside an equation like this, we want to get rid of those fractions by multiplying by the LCD. And we see that between these three terms, our LCD, it's got to have an x minus 2, it's got to have an x plus 5, and that will take care of that last fraction, which is x minus 2 times x plus 5. So we're going to multiply each of these terms by that LCD. Make sure that you multiply every term by the LCD, even if it doesn't have a fraction. Right? And the whole goal of doing that is so that we can now get rid of those denominators by dividing out those common factors. Our first fraction, we've got an x minus 2 common. On our second fraction, we've got an x plus 5. And then our last fraction, both of those denominators, both of those terms are going to divide out. So on the left-hand side, we're going to be equal to x plus 5 times 3. On the right-hand side, our first term is going to be x minus 2 times negative 3. And then the only thing that survives from this last term is that coefficient of 15. And now this looks like a linear equation. So let's go ahead and distribute and combine like terms. So we'll get 3x plus 15 equals negative 3x plus 6 plus 15. Move all of our x's on one side, so we'll add 3x to both sides, and then get our constants on the other side. We'll subtract 15. So on the left-hand side, we're going to be left with 6x. On the right-hand side, those x's go away, the 15's go away, and we just have 6. And so x equal 1 is our potential solution. You always want to check this. The main thing that you're wanting to check is, does that make your LCD equal to 0? Typically, if you did everything right, all of your arithmetic was right, and it doesn't make your LCD equal to 0, that'll be your solution. But the best thing to do is to always check by plugging back into the original. So we get 3 over 1 minus 2 equals negative 3 over 1 plus 5. Plus 15 over 1 minus 2 times 1 plus 5. On the left-hand side, we're going to get 3 over 1 minus 2. That's going to be a negative 1 in the denominator. So 3 divided by a negative 1 is a negative 3 on the left. On the right-hand side, we're going to get 1 plus 5, or 6 in the denominator. So negative 3 divided by 6 is negative 1/2. And then on our last term, we're going to have negative 1 times 6, so that's going to be a negative 6 in the denominator, and 15 divided by a negative 6, it's going to make that negative. There's a common factor of 3. 15 and negative 6 have a common factor of 3, so that's going to reduce to 5 over 2. And we do see that negative 1/2 minus 5/2 is going to give us a negative 6/2 on the right, and negative 6/2 is equal to negative 3. So we did all of our arithmetic correct on that problem. All right, let's go on to our next problem. We have the equation 4 over y plus 5 plus 2 over y minus 2 equals 6 over y plus 4. So a similar approach on this one. The only difference is that our LCD is going to include all three of those denominators. There are no common factors. So our LCD is going to be y plus 5 times y minus 2 times y plus 4. We're going to multiply each of those terms by that LCD. And reduce those fractions just like we saw in the previous problem. So our first fraction, we have a y plus 5 in the denominator, so that'll divide out, and we're left with y minus 2 times y plus 4 times that 4 in the numerator. On our second fraction, our y minus 2 is going to divide out. So we get y plus 5 times y plus 4 times the 2 from the numerator. And then our last one, our y plus 4 is going to divide out, and we are left with y plus 5 times y minus 2 times 6. So same approach that we took on the last one. We want to multiply, expand these as much as possible, and combine like terms. So if we multiply this out, I'm going to go ahead and distribute the 4 and the 2 and the 6 to that second one. Remember, when we're multiplying, doesn't matter what order we multiply them in. So this is going to be 4y plus 16. And our second term, we're going to get 2y plus 8. And our last term, we're going to have 6y minus 12. All right, so now when we multiply that out, that'll be 4y squared plus 16y minus 8y minus 32. For our second term, we're going to end up with 2y squared plus 8y plus 10y plus 40. And then 6y squared minus 12y plus 30y minus 60. All right, combining like terms on the left-hand side, we do have a minus 8y and a plus 8y. And that's the only thing that's going to cancel out. So 4y squared plus 2y squared is 6y squared. 16y plus 10y is 26y. Negative 32 plus 40 is going to be plus 8. And then on the right-hand side, we get 6y squared. Negative 12y plus 30y is going to be a positive 18y minus 60. And if you notice, we have a 6y squared on both sides. So if we move those all onto the same side, those are going to add to 0. So let's go ahead and we'll subtract our 8 and subtract our 18y to get, it's going to give us 8y. Those 8's add to 0, our 18y's add to 0, and negative 68. And if we divide both sides by 8, we get y equals negative 17 over 2. And 17 over 2 is not going to make our LCD equal to 0, so assuming we did all of our math correct, that one will work. We can check that by plugging it in on the calculator if you would like, but I'm going to, for sake of time, I'm going to skip the check on this one, though I strongly encourage you to check it even if you're plugging in on the calculator. All right, I've got one more example I want to get to. We've got x over x squared minus 9 minus x plus 2 over x squared minus 3x equals negative 4 over x squared plus 3x. So remember, to find the LCD, the first thing we need to do is factor all of our denominators. So x squared minus 9 is going to factor to x plus 3 times x minus 3. X squared minus 3x, we have a GCF of x there, so we'll get x minus 3. And then x squared plus 3x also has a GCF of x, and it's going to leave us with x plus 3. So on this one, our LCD is going to be x plus 3, x minus 3, and then this last two fractions also have an x in there, and so our three factors for our LCD will be x, x plus 3, and x minus 3. Just like we've saw in the last two problems, we are going to multiply both of those by our fraction. Alright, so we've got everything multiplied. We can now look at dividing out our common factors. We have an x minus 3, x plus 3 on our first denominator. Our second denominator has an x and an x minus 3. And then on the right hand side, we've got an x and an x plus 3. So for our first fraction, we're only left with our x out front and the x in the numerator, so that's going to give us x squared. And then we get x plus 3 times that numerator of x plus 2. And then on the right hand side, we have x minus 3 times negative 4. And this again looks like a quadratic, but let's go ahead and see if what happened in the last two with those x squareds canceling out happens again. So let's go ahead and expand, multiply this. We need to multiply x plus 3 by x plus 2, and we're going to have x squared plus 2x plus 3x plus 6. But we do have a minus sign out here, so we want to make sure that we subtract that whole thing by putting it in parentheses. So we'll distribute that negative. On the right hand side, if we distribute that negative 4, we get negative 4x plus 12. Let's distribute this negative real quick. So when we combine like terms, x squared and negative x squared are going to add to 0. Negative 2x minus 3x is negative 5x minus 6. And on the right hand side, we get negative 4x plus 12. I do like to keep my coefficient on my x positive, so I am going to move my x's to the right hand side on this one. It does not matter, you'll end up in the same step. Here in 2 steps, we'll have the same two numbers equal to each other, but I like keeping my x positive. And so I'm going to move my constant to the left and my x's to the right. When we do that, we're going to end up with negative 18 on the left and x on the right. And we can check that. First thing that you want to make sure is that the solution that you get does not make your LCD equal to 0. And if we plug in a negative 18, we're not going to get 0 for any of those three factors. And so we won't get 3 on our LCD, or 0 on our LCD. And you can plug that back in, use your calculator if you need to check and make sure that that does actually give you a true statement, and it should. And I will see you guys next time.